everyone, in this lesson we're going to differentiate algebraic functions using the product rule. So this video is, like I said, very specific towards algebraic functions. You will not see any transcendentals like e to the x, natural log, no trigonometry. So this is just specifically for algebraic functions. So the first question is, what is the product rule? And the product rule is just a formula for differentiating a problem in which we have one function multiplied with another function. So as you can see here, we are looking for the derivative of a function f of x times another function g of x. There's a couple ways you could write this formula, but this is the way that I always write it. And you'll see why later on in this section, because when we cover our next rule, which is the quotient rule, it follows a similar pattern. So I like this pattern in writing it. First, we take the second function, which is g of x, and we're going to multiply it by the derivative of the first function. Then we're going to add the first function times the derivative of that second function. Hello everyone, so we're going to have a little bit of fun here in my kid's playroom using his easel, because I really think these types of problems are easier to see when you can actually see me writing out all of the work in real time. So we'll see how this goes. So for this problem here, I have to find the derivative of the product between negative 2x to the fourth minus 3 and negative 2x squared plus 1. So my product rule, we have g of x times f prime of x, so g of x times the derivative of f, plus f times the derivative of g. So if it helps you, you can label which function is which. I'm going to call this one my f of x, and this one my g of x. Okay, so I have, again, I'm going to write out my product rule, g of x times the derivative of f of x plus f of x times the derivative of g of x. So g of x is negative 2x squared plus 1. The derivative of f is going to be the derivative of negative 2x to the fourth minus 3, which is negative 8x to the third. F is negative 2x to the fourth plus 3. Sorry, minus 3. And the derivative of g is going to be negative 4x. Now, I would never leave it like this. We always want to simplify completely, which means distributing and combining like terms. That's always a given. Okay, so I'm going to multiply this. This is just distributing that negative 8x cubed. So I have a 16x to the fifth minus 8x cubed. Here I'm distributing that negative 4x. So I have a positive 8x to the fifth plus 12x. And then lastly is combining those like terms. So the negative 16x to the fifth and the 8x to the fifth gives me a 24x to the fifth minus 8x cubed plus 12x. In this next problem, we have negative 3 plus x to the negative third power times negative 4x cubed plus 3. So again, since we see a product of two different functions, I'm going to use the product rule in order to differentiate. So g of x is negative 4x cubed plus 3 times the derivative of f, which is negative 3x to the negative 4, plus f of x, negative 3 plus x to the negative third, times the derivative of g of x, which is negative 12x squared. Just like the previous problem, we're going to simplify by using the distributive property and combining any like terms. So here I have 12x to the negative 1 power, because again, when we're multiplying variables, we add the exponents together, minus 9x to the negative 4, plus 36x squared minus 12x to the negative 1. So when we combine like terms, we see the 12x to the negative 1s are going to cancel. We're left with, again, writing in descending order, 36x squared minus 9x to the negative 4. You could also rewrite this if you want to have positive exponents, 36x squared minus 9 over x to the 4th. Either one of these answers, I would accept. They're equivalent answers. All right, in this example, we have negative 10x squared minus 7, the 5th root of x squared plus 9 times 2x cubed plus 4. So again, I could easily see there's a product here between these two expressions, so I'm going to use my product rule. G of x is 2x cubed plus 4. F prime, derivative of that first expression, is negative 20x minus, now remember we have the 5th root of x squared. That can be written as x to the 2/5 so that we can use our power rule. Bringing the 2/5 down, negative 7 times 2/5 is a negative 14/5. X to the, subtracting 1, negative 3/5. Derivative of 9 is 0. So that's the end of that expression. Plus, next we have f of x, which is negative 10x squared, minus 7x to the 2/5 plus 9 times the derivative of g of x, which is just 6x squared. So that one isn't too bad. Now we have to multiply this whole thing out so that we can simplify it. This is a binomial because there's 2 terms times 2 terms, so I'm going to have to multiply this thing out. 2x cubed times negative 20x is a negative 40x to the 4th. 2x cubed times negative 14x to the 5th, x to the negative 3/5. 2 times negative 14/5, that's negative 28/5. X cubed times the x to the negative 3/5. Remember, we add the exponents together. 3 is really 15/5 minus 3/5 gives me 12/5. Multiplying now the 4 inside of here, we have a negative 80x minus a 56/5 x to the negative 3/5. Phew, so that thing is done. Last is to multiply out that second half. Negative 60x to the 4th minus 42. Again, I'm adding these exponents together. 2 is really 10/5. So I have an x to the 12/5 again. Plus, I got to squeeze it down here, 56x squared. Combining all our like terms that we have. So again, going in descending order, my highest exponent here is going to be the 4. So I have negative 40x to the 4th and a negative 60x to the 4th, negative 100x to the 4th. Those are taken care of. Now I have this negative 28x to the 12/5 and a negative 42x to the 12/5. So 42 is going to be what in fifths? 210. So I have a negative 210/5 minus 28/5. That's going to give me a negative 238/5 x to the 12/5. 12/5 are done. Next we have the first power. Second power. Plus 56x squared minus 80x, first power, and then we have our negative power here, negative 56/5 x to the negative 3/5. Not the prettiest answer that we've had, but it's doable. Take your time through these problems and make sure that you're paying attention to all of our rules for real numbers. That's what we're using. We're using exponent rules. We're using multiplication. We're distributing. We're combining. These are all skills that are based on properties of real numbers. So always keep those properties in mind and just take your time through these. So I realized after filming this that I did make a mistake, which is why I emphasize taking your time, because if I took my time, maybe I wouldn't have made this mistake. 9 times 6 is 54, not 56, so I have corrected that here.